Hey there, thanks for checking out this demo. Today I'm going to go over how I set up this clot and how I use dynamics to get fibrin to intertwine among the red blood cells, and then I'll show how I added the subtle animation to it. I created a cluster of RBCs by first creating a sphere, then adding a cloner, and placing a single RBC model as a child beneath the cloner. I put the cloner into object mode with the distribution set to volume, and told it to use the sphere as the object to fill with RBCs. This creates a bunch of RBCs inside the sphere. I've started with 65 clones, but we'll see how things go and we might need to increase or decrease that amount. To get the RBCs to clump together, I'm going to use dynamics. I've used a pose morph to shrink a sphere, and the brush tool to push the sphere's points around into the shape that I want the final clot to be. This shrinking sphere is what's going to press all of the RBCs together dynamically. I'm going to get rid of the dynamics tags and add them from scratch to show what settings I used. For this part of the setup, in version 2024 of C4D, I'm going to use the old bullet solver dynamics. We'll start by adding a rigid body tag to the cloner, and we'll set the bounce to 0%. Next, we'll add a collider tag to the shrinking sphere. Before we hit play, it's important to remember to set the world gravity to 0. We do this by going into the scene settings, and since we're using the bullet engine, we go to the bullet tab and set gravity to 0. As we hit play, we'll see that the shrinking sphere pulls most of the RBCs together. Some manage to evade capture, but that's not a big deal. We'll take care of those elusive RBCs in a moment. The next step is to cache the dynamic simulation. Once we have the dynamics cached, we run the current state to object function on the cloner and turn the clones into actual geometry. At this point, we can select and delete the RBCs that eluded the dynamic capture. Now, we'll rinse and repeat for the other side. Once both sides are baked down by using current state to object function, we'll duplicate both of them, then run the connect and delete function to convert all of these individual RBCs into a single mesh. Then we'll hide the originals for now. Next, we'll add a field force object to our scene. We need something for that field force to affect, so we'll create a cloner of spheres. We're working at a pretty small scale in this scene, so I'll set the diameter of the spheres to 0.3. In the cloner, I'm going to use object mode and clone these new spheres onto the surface of the single mesh of RBCs we created just a moment ago. Distribution mode will be left to surface, and we'll up the count to 250 for now. As we zoom in, we see that the center of the cloned spheres are clipping through the surface of the RBCs. By going to the Transform tab of the cloner and offsetting the Z value by 0.4, the spheres no longer clip, but are just above the surface. This will be important in a minute when we start working with the dynamics. Let's reduce the sphere segments. Since order of operations is important in C4D, I'm going to move the cloner beneath the object that it's being cloned onto. Now, we want to get the fibrin starting to intertwine with the RBCs. We'll use the new dynamics engine. We'll right-click, go to Simulations, and add a rigid body tag to the cloner of spheres. On the single mesh of RBCs, I'll add a collider tag, and this will prevent the spheres from clipping through the single mesh of RBCs. Before we start playing with the settings of the dynamics, we need to disable the gravity for the simulation dynamics in Cinema. So we'll go to Edit, Scene Preferences, and then to Simulate, and to the Scene tab. Here is where we'll find the value for gravity for the simulation dynamics, and we want to set it to 0. Now if we hit play, we see that all the spheres bounce away. So let's check the field forces object, and now we see that we have no field assigned. I want these spheres to be attracted to the surface of the single mesh of RBCs. So to do that, I'm going to drag the single mesh of RBCs into the field menu of the field forces. Now all the spheres will be attracted to the nearest surface of the single mesh of RBCs. Let's increase the strength to 15, and in the direction of the mesh, let's change the direction length to no remap. All of these lines showing where the field force is working is a bit distracting to me. So let's go to display and uncheck the display box. Now hit play again and see how things are looking. Spheres are going everywhere. Okay, so let's look at the dynamics tag. On the cloner spheres first, since we're working at such a small scale, let's change the thickness from 1.5 to 0.05. While we're here, let's also turn down the friction. And now let's also turn down the friction in the collider too. Now for rewind and play, we start to see the spheres moving across the RBC surface. Alright, looking good, but let's make them move more by adding a random field above the RBC mesh and change its blending mode to add. And we'll increase its animation speed to 100%. Now the spheres are crawling along the surface nicely. I'll get the actual fibrin spline by using a tracer. If we click on the cloner, then create a tracer object, the cloner will automatically be added to the objects that it's supposed to trace. And we need to tell the tracer to trace immediate clones. Wherever the cloned spheres crawl, the tracer will trace their path into a spline. From here, it's a matter of letting the simulation play and adjusting some parameters to get the meshwork of the fibrin to look just how we want. Changing the cloner seed will change the starting position of the spheres. Changing the random field seed parameter will change how the random noise animates over time. Once we're happy with how the fibrin looks, right-click on the tracer and current state to object to bake this down into an editable spline. Now let's shift our focus to giving this clot some organic motion. Hide the cloner of spheres and the collider mesh and unhide the separate RBCs that we hid previously. Create a fracture object and place all of the RBCs beneath it. The red color goes away, but we can add that back from the Transform tab. Now, let's add a random effector to the fracture object. We'll change its mode to noise and reduce its animation speed. Also make sure that the indexed parameter is checked. In the Parameter tab, let's determine how much each of the RBCs should move and rotate by setting the position and rotation values accordingly to our liking. Next, let's make the fibrin spline move a bit. If we go into point mode, we can see that there's a lot of points. We can reduce that point very quickly in Cinema 4D 2024.2 or later by looking in the asset browser and searching for the node operator called resample spline. Place this node operator as a child of the spline and start reducing the count value. Lower this value as much as possible while keeping the general shape. It will start to look jagged, but we'll fix that in a moment by changing the spline type. Once we're happy with the overall shape of the fibrin spline, run the current state to object command to bake down the spline with a reduced vertex count. We can now disable the original spline with the high vertex count and focus on the new spline. Change the new spline type from linear to cubic and set its intermediate points to uniform. Now let's create a deformation driver. Add a sphere to the scene and make it editable. By using the brush tool, push the points around until it encapsulates just one side of the fibrin spline. Looking back at the fibrin spline, we have a single spline for both sides of the clot. I want to split that up into two splines for better control over the deformation. So we'll duplicate the entire spline and select all of the points on one side and delete. Then we'll select all of the points on the other spline and delete those as well. Back to our deformation driver, create a displacer to deform the geometry and add a noise into the shader field. In this noise, increase the scale a bit and turn up the animation speed. If we press play, we see that the deformation driver is now deformed and animated. Before we go any further, let's disable all of our dynamics tags just to make sure that dynamics are not being calculated in the background and causing anything to slow down unnecessarily. Let's name some of our objects so we know what's going on later. And we'll select the left side of the fibrin spline and create a mesh deformer as a child. This is what's going to deform this part of the fibrin. Drag the deformation driver we just created into the cages box of the mesh deformer and click Initialize. Open the advanced parameters and select Surface. And we see that the fibrin spline is animated. But this amount of deformation might be a bit much as the spline is starting to clip into the RBCs. So we can reduce the strength of the displacer underneath the deformation driver object and reduce how much the fibrin spline is moving. To make the spline visible in your renders, we can add a sweep and lower the diameter of the profile a little bit. Or if your render engine supports spline rendering, just add the appropriate tag. Now it's a matter of rinse and repeat for the other side, and your clot is ready to start lighting and texturing. Thanks for watching. Let me know if you have any questions or comments below, and I'll catch you next time.